Morning. All right, let's get started. Today, we are going to go over the homework for section 2.2. And then I have something else I want to talk about today, but we can do that later. So any questions that you would like me to answer over section 2.2? Yes.
Can you do number 38?
38? Sure. Okay, so yeah. These kind of chart problems. So number 38, we have the limit as x goes to 2 of x squared minus 4 divided by x squared plus x minus 6. Okay, and then they want us to do some stuff. They want us to plug in some various x values, like 1.9, 1.99, 1.999, and then 1.9999. Okay, and then they want us to plug in that x could be 2.1, 2.01, 2.001, and 2.0001. And then see what we get out, so to speak, for our limit. Well, not our limit, but x squared minus 4 over x squared plus x minus 6. Same thing here, x squared minus 4 over x squared plus x minus 6. Okay, so what I will need your help a little bit on is if somebody has a calculator, maybe. Does anybody have a calculator with them, actually? If you do, pull it out, and maybe you can help me out here. So we need to plug something into this for x and see what comes out. And kind of the goal of these problems, right, is the concept of the limit is as I get close to whatever number this is, in this case, the number 2, from both sides. So this is getting closer and closer to 2, 1.9, 1.99, 1.999. So over here, 2, we're getting close on this side, and we're getting closer and closer and closer on this side. And as we get close together, are we seeing it get close to something? And hopefully the answer is yes, okay, that it's getting close to something. And so we just need to kind of figure out what are these different values. I guess the question is, was that your question, or was it more plugging it in itself?
It was, yeah, just kind of figuring out what the actual is.
What the actual, like, plugging in these values is.
Yeah.
Yeah, so like this is kind of like an exercise in calculator. But so the big thing if you're using your calculator is you can never use too many parentheses. You know what I mean? So like if I was plugging it into my calculator, it's kind of like parenthesis, let's say 1.9 squared minus 4, and figure out what that is, right? And then you got to divide that. If you are putting it all in at one time, you'd need to do something like this. Like if you wrote that in your calculator, that should be right. The problem that we usually have when we enter these kinds of things is like we go one parenthesis too few, and somehow it just like messes it up. Like if you erase this parenthesis, then maybe it will just divide it by this number, but not this. So it can be tricky to enter these into your calculator, but just overuse parentheses, and typically you're fine. So just plug these things in and get these. And ultimately, I don't know if we've done a lot of, in my lesson, using algebraic means of figuring this out, but do we know the answer? Well, if we were to factor this thing, which is a little bit more of what we would do in the future, is we get x minus 2 times x plus 2 on top. And on the bottom, what does that factor to? X plus 3, x minus 2. Does that seem right? Okay, and so typically in the future, we'll just say, okay, so the x minus 2's cancel. And now we could plug in 2 to the top and bottom, and we get 4 on top, and we get 5 on the bottom. So it should be getting close to 4/5 once you get all these plugged in. Hopefully the numbers are all getting close to this number 4/5, approximately. The problem with this method of computing limits is, for example, I mean, it is good if you don't know what else to do. Like if you did not know how to take a limit, then this is a very efficient way of getting a feel for, does this thing have a limit and what is it approximately? But you could never really know for sure if it was 4/5 just by doing this. Okay, like what if the answer was to a limit, the answer is pi? How do you squeeze in far enough on the number pi that you know that it's the number pi? You never would. You could never squeeze in tight enough to be able to say certainly that, oh, that's pi. You just couldn't do it. It goes on forever, right? So this method is helpful to kind of see, oh yeah, I think it does have a limit. And I think its limit is approximately this. But to get like an exact answer for a limit, then we need to do something more algebraic like I did right here. And like maybe factor it, cancel some things, and so forth. Something that I talk about maybe in the lectures online, but it's worth saying one more time, is I did something up here, and it's always like scary to do such things. So, but let me talk to you about this for just a second, since I just did it. And that is I canceled this x minus 2 on the top and on the bottom, right? So what I did is I said something like the x minus 2 times x plus 2 over, and then I had x plus 3, x minus 2. Now, let's just take this as a function. And the question is this equal to x plus 2 over x plus 3? Is this something I talked about in the online lecture? I may or may not have. I'm not sure. Does anybody remember? Doesn't seem familiar. Maybe a little bit. Okay, anyway, I'll talk about it now because it's interesting. What do we think? Are those two things the same? So some people are saying yes, some people are saying no. People saying yes, does somebody want to volunteer to tell me why they think that's the same? Yeah.
I'm pretty sure that if you multiply both the numerator and denominator by x minus 2, and you can also divide both the numerator and denominator by x minus 2.
Okay.
And because of that, you can simplify it.
Mm-hmm. Yeah, so that's very good. So the argument was, well, couldn't I multiply the top and bottom by something like x minus 2? So certainly I should be able to cancel them out and make a 1 and then just write this. So it's like, okay, I hear that. Somebody who said, no, they're not the same. Yeah.
Because if you plug in 2 for x, then the bottom of the left one becomes 0, but the bottom of the right one is 5.
Okay, so the argument there is like, well, come on. What if x is equal to 2? Yeah.
Can you put 2 in for x and you still have 1 because
It's a good question. And that's kind of why we're having this discussion is, which is it? Well, if X is 2, let's say that X was 2, what's the top become? 0. And the bottom? 0. 0 over 0 is like a bad day in math, right? So that's not good. And so we can't really cancel a 0 over 0. But we can cancel any, if X were any other number, then we can cancel it. So at the end of the day, this is kind of like a little tiny thing, but it's worth talking about because it's kind of the whole concept of a limit. At the end of the day, those are not the same. These are not the same function. Because if I drew these two functions, one of them would have a hole in the graph at the value X equals 2. This one does not. And so what I kind of do if I say that these two things are equal is I fill in the hole. And then they are equal other than that one spot at 2. But then you say, well, if those aren't equal, didn't you just say that they were equal? Well, no, I didn't. What I said is that their limits are equal. Okay, so this is not the same, but this is. That is the same, because one thing that's assumed when I'm taking the limit is X goes to 2, there's one number that I know I'm not worried about, and that's the number I'm going to. I'm worried about numbers around 2, not at 2. Does that make sense? So if I say the limit is X goes to 2, the one number I know that X is not is 2. And so I can cancel the X minus 2's because I know X isn't 2. If it could be 2, then I can't cancel it. Question?
Yeah, so I'm just wondering, would those two functions have the same graph except for that one point?
Yes, that's right. So like, for example, let me use something maybe just a little simpler. So let's say that I had X minus 2 over X times X minus 2. And we would say that this is sort of kind of like, but not really, 1 over X, right? These aren't the same, but their limits are the same. So one of them, this one, would look something like this. 1 over X looks like this. Except this one, it can't be evaluated at 2. So out here at 2, it would just have a hole. This one can be evaluated at 2. So this one's just the one we know and love. So they are exactly the same graph, except at the value 2. And that's why we say they're not actually the same function. They don't even have the same domain, because 2 is in the domain of this function, but 2 is not in the domain of this function. Does that make sense? So this is a subtle thing, and for most of the time we're doing calculus, like we wouldn't even have to think of this, and it's fine. But it's good because it reinforces like what is a limit. And a limit is what's going on around that point. Not at it. Wow, I hate it when I do that. Okay, not at the point, right? And so this really drives that point home, that we can't just go around canceling things with X in it willy-nilly like this. But we can do it if it's a limit and the point at which we're canceling is where it would be 0 over 0. Then we can do it and it's fine because we know that X is not 2. And that's kind of the key to this algebraic limit process. Okay. That was a long answer to like this chart, but I think it's a good thing to talk about. Okay, do you feel like you could fill this chart out now? You're good? Okay. Other questions? Oh, I have some online too. Yeah.
When we put the questions in the homework, do you want us to write down the questions too, or can we just write?
You don't have to write down the questions. No. Only write down the question if it's like helpful to you in some way to write down the question, but no, you're not going to get graded down for not writing down the question. Yes. When do we turn them in?
No, how do we turn them
Oh, how do you turn them in? You do need to upload a PDF of your work to Foxtail by 11 tonight.
in?
Yeah. Okay, so yeah, in general, if you can use fractions, you won't get counted wrong per se for putting in a decimal. And it also depends on the problem itself. Like here's a problem where it has a bunch of decimals in it. If you used decimals, that's fine, because it's already like starting you with decimals. So I wouldn't expect you to use exact values when they gave you decimals to work with. But in a problem where you could use exact values and you chose to use decimals, I would say that it's a good habit to use fractions. So what would an example of that for me would be like if somebody wrote like 0.3 repeated as their answer or something, I would be like, come on, that's a third. You know what I mean? But so like I said, if they give you decimals in the problem, it's fine if you use decimals in the answer. If they don't, I would say don't convert to decimals in the problem. Like if they give you a 1/4 and you say, I don't like 1/4, I'm going to use 0.25, don't do that. Okay, so don't convert over to decimals. Other questions? Let me see, somebody's writing on here. Somebody asked if 2.3 was included in this assignment, and the answer is no. 2.3 will be due on Wednesday. Okay, let's see. So for problem 41, they had a problem finding the limit as they filled the chart. Okay, so let's look at number 41 really quick. I doubt I'm going to fill the chart up either, but we can talk about it for a second. So 41, we have the limit is z goes to 0 of z minus 1 divided by z squared times z plus 3. Okay. And the question is, what happens here as z goes to 0? Well, something I see right off the bat here is as z goes to 0, bad things are happening because there's division by 0 on the bottom, but there's no corresponding 0 on the top. Okay, so what that tells me is this thing is either going to infinity or it's going to minus infinity. Okay, or it could be going to one side, one way on each side. So to me, when you're filling in the values, one side of this thing, like as you get close to 0 from the left, where you're coming in for like 0.01, 0.001, 0.0001, then it's either going to be getting really, really big or really, really small. And I mean like really close to positive infinity or really close to negative infinity, so to speak. And then as you come in from the other side, same thing. It could go either way. So, but what I can say for sure, just looking at this, is it's not going to go to some nice number. Okay, it's either going to go positive infinity, negative infinity, or neither, because they're going in either direction. But maybe we could just figure it out on our own. Like if I plug in something just a little tiny bit bigger than 0, I don't really even care what it is. What's the top, positive or negative? Negative, right? Because if it's just a little tiny bit bigger than 0 and I subtract 1, the top would be negative. What about the bottom? This is positive no matter what I do. And then if I take something just a little bit bigger than 0 and add 3, it's also positive. So I get something negative over positive, which is negative. So this must be getting huge and negative. Does that make sense to everybody? So it would be negative as I came in from the right or the positive side. What if I started with something slightly smaller than 0? If it was slightly smaller than 0, something slightly smaller than 0 minus 1 is still negative. If it's squared, it's positive. If it's slightly smaller than 0 and I add 3, it's still positive. So it still ends up being negative. So it's going to negative infinity on both sides, which tells me that it's going to negative infinity. Does that make sense to everybody? So I could fill in the chart and kind of see this happening as I get closer and closer from both sides. But at the end of the day, I can just kind of look at it a little bit and say, okay, looks like that's going to minus infinity. Hopefully that's helpful to whoever asked the question online. Other questions? Yes?
So the answer for number 41 be negative infinity?
Yes, so that's not the answer to the chart. The chart, you actually have to go in and plug in those values. But if you're trying to actually evaluate what is the answer to this thing, it would be minus infinity, yeah, to the limit. Yes?
What's your expectation for the work shown?
On a problem like this, or just like in general?
Like in person?
Yeah, I mean, just show your work. Like if something's really, really easy and you can do it in your head or something, it's fine. We won't be there very long. You know what I mean? So I'm not so worried about it. There's an expectation that you do show all your work. So whatever you're doing to do the work, turn that in. So if there is something very easy where it's like, oh, I can just figure that out in one step, well, good for you. That's fine for now. Yeah. Other questions? Yeah, the one thing I would say about that isn't so good is if I think magic occurred, that's probably not good. Do you know what I mean? It's like, that's magical. How do you do that? That's not good.
Can we look at 76?
Sure. 76. Okay, so it says sketch the graph of a function with the given properties. So 76. So we've got the limit as x goes to 2 of f of x is equal to 1. We've got that the limit as x goes to 4 from the left of f of x is equal to 3. We've got that the limit as x goes to 4 from the right of f of x is equal to 6. And we've got x equals 4 is not defined. Okay. So we just need to draw a function that has all these things. And the first thing that I see is that, okay, the limit as x goes to 2 of this function is 1. So if I come over here and I go out to 2, then I know that its limit is 1. So from the right and from the left, this is getting close to the value 1. So I know I'll put a little circle here, and I know from the right and from the left, it's getting close to 1. Okay, then it says that as it gets close to 4 from the left of f of x, I get 3. So here's 3, here's 4. So as I get close to 4 from the left, I get 3. So here's 2, here's 3. So as I get close from the left, I get 3. Then it says as I get close to 4 from the right, I get 6. So 3, 4, 5, 6, here's 6. And it's getting close there. And then it says that at 4, this function's not defined. So I don't have to fill in anything. And now I just kind of connect the lines. So I can say, this could do whatever it wants to. Maybe it goes up this way. This can do whatever it wants to. And I suppose this point at 2 could do whatever it wants to. It could be there. It could be up here. It doesn't really tell me anything about where the functional value of 2 goes. So I'll just put it right here. But it does say there's no value in 4. So here would be an example of a problem. I'm sorry, an example of a function that has all those properties. Yes, sir.
So for the third one down, f of x equals 6, does that have to connect to f of x equals 1 at the top because it says the limit of x if it goes to 2?
Okay, so this is saying right around 2, it looks like the functional value will be 1. So right around 2, on both sides of 2, it looks like I'm getting close to 1. Does that make sense?
Okay, so it's accounting for the 4, yeah. Okay.
So this is the one you talked about, right? This
Yeah.
one? Yeah, this one says, as I get close to 4 from the positive side. So as I get close to 4 from the positive side, it looks like it's going to hit 6. So as I get close to 4 from the positive side, it looks like this function's going to hit 6. Does that make sense?
Yeah.
Same thing here. As I get close to 4 from the negative side, it looks like it's going to hit 3. So as I get close to 4 from the negative side, it looks like it's going to hit 3.
Right.
Does that make sense?
Yes.
Okay. Other questions? Yes, sir.
So for like the one that's on like 2,1, how it's not filled in,
Oh, yeah.
would it have to be f of 1 for it to be filled in?
Yeah, so if this right here,
Yeah.
so it doesn't, this problem doesn't tell me anything about f of 2. All it tells me, and I filled it in this way kind of on purpose just to show that we don't know. All it tells us is what's going on around 2.
Okay.
So around 2, it looks like it's going to hit at 1. At 2, maybe it does hit at 1. I don't know. Maybe it doesn't hit at 1. Maybe it doesn't exist at all. So it's kind of like it doesn't tell me in the problem, so I can just do whatever I want to. So I decided to put it up here just for fun. But I could have put it in here and filled in the hole, and that would have been fine too. Does that make sense?
Yeah.
So it just doesn't give me any information about what happens at f of 2.
When we're doing this one, would you want us to put the circle on the line, or would you be fine with just the line going through that point?
Oh, like for this?
Yeah.
I mean, if you would have just written this, that's great. Yeah, because now the limit is still 1, and it just happens that f of 2 is 1 in this case. So it's the only reason I drew the circle in is because that was like a special point, right? 2 was a special point in this problem. So I gave it a little circle just so I could draw my lines into it, but you don't need the circle there unless something weird were happening at 2. Anything else? Okay, let me see. Anybody else asked a question? No. Anything else from online? Yes, sir.
Can we look at 52 real fast?
Sure. 52. Oh, yeah. So we've got this function. So we've got a function that they give us here. At 1, go up 1, 2. So that's filled in. Go this way. This goes this way. Okay. All right. And then you said 51? 52. Okay. So then they're just asking, what is the limit as x goes to 1 of f of x? Yeah. So in this case, what it means for the limit as x goes to 1 to exist would mean that it does have a limit as it comes in from the left. And this one does have a limit from the left, it's 1. It has a limit from the right. As it comes in from the right, it looks like it's going to hit 2. And then those two need to be the same. And in this case, since the limit from the left and the limit from the right are different, then we would say that this limit does not exist. So there's no limit here because the limit from the left and the limit from the right don't match up. Does that make sense? Yeah, so it does not exist.
Can you do 54 as well?
Sure. So 54. Oh, we just have f of 1. Yeah. So this was 52. Oops. 2, 4. It says, what is actually f of 1? Yeah, so f of 1 in this case, it's just where is the actual dot. So the limit saying what's going on around 1, f of 1 is saying what's going on at 1. So at 1, we're actually landing on, in this case, 1. Does that make sense? All right, I think we're probably good to go on this section. So I will assign the next lecture. So watch lesson number 2, and then you can start working on the second homework assignments, and we will talk about that on Wednesday, okay? Have a good day. I'll see you then. Yes, sir.
I have a logistical question. So for Friday, I was supposed to be online for YouTube, but I accidentally came to class.
Oh.
Is there like any attendance thing?
No, you're fine.
And if there's an extra seat for those coming in person.
That one is kind of tricky because I just can't let everybody do that.
Yeah.
Let's see how it goes for like a week.
Okay.
And then if I'm noticing that we are consistently having some open chairs, I'll let you know.
Okay, thank you.
Yeah.
What about keep that on email or?
Email's good, or you can come by my office hours too. Either way is good.
Awesome.
Yep, have a good day.
When would the next homework be assigned after this one? So that not the one that's due on Wednesday, but
I'll have one due on Friday as well.
thank you.
Yep.